Chapter 8 is graphing quadratic functions. 8.1, graphing f of x equals ax squared. Okay, so we're first going to graph y equals x squared, which is the simplest possible quadratic function. This is going to be called a quadratic function when we have x squared in the equation. Okay, when it's a second degree equation at least. Okay, so since we haven't graphed a parabola before, this is going to be a parabola when we graph these. We're going to do an xy table. Okay, so you can use this method to graph any type of function. If you don't know what it looks like, just make up some x values, plug them into the equation, and see what y's you get with them. That'll give you some points on the graph and give you an idea of what it looks like. Okay, so I'm going to first start with by plugging in 0 for x. So 0 squared is going to be 0. Okay, so when you plug 0 into this, you get 0. I'm just going to be squaring these x terms, right? So I'm not going to write this out for each of them. But if I plugged in a 1, I'd have y equals 1 squared. 1 squared is 1. 2 squared is going to be 4. 3 squared is 9. Okay? When I get to the negatives, let's think about this. I'm taking the quantity -1 and squaring it. So -1 times -1 is positive 1. Okay, and -2 times itself would be positive 4. -3 times itself is positive 9. Okay, so let's plot these points. We got 0, 0. We have 1, 1. 2, 4 is going to be right here. 3, 9 is going to be in the very top right corner of this graph. Okay, and then we got -1, 1. -2, 4. And -3, 9 is in the top left corner. Okay, and hopefully you can see that this is starting to curve a bit. It's not just a v like an absolute value function. It has a curve to it. It looks more like a u than a v. So it's going to look something like this. Okay. The next point out would be 416 and then 525, and so it's curving up. And it looks like it's going to just turn into a vertical line, but it actually will keep going out forever. It's getting closer and closer to a vertical line as it goes up. Okay. All right. So a little bit of that's going to be our parent graph. We're going to base all of our other graphs of parabolas on this graph. So hopefully you'll memorize the shape of this. So you go up one to the right one, and up one to the left one, and you go up 4 to the right 2, up 4 to the left 2. If you remember that, that will go a long way. Okay. Just like these 5 points there. If you remember how that looks, that'll help. Okay. All right, so a little bit of vocab. Here's a parabola. This is a quadratic equation would fit this. This line in the middle, this dashed line, is called the axis of symmetry. And that cuts the parabola into 2 equal halves, right? It would be a mirror image of itself. So you could fold the parabola in half over that line and it would match up perfectly. So this is a vertical line that divides the parabola in half. Okay? And there's a formula for that, and we'll get to that later in the chapter, but we don't need the formula yet. It's going to be x equals -b over 2a in case you need that now. But all right, the vertex is going to be the point at the very bottom of the parabola. Sometimes you'll have a parabola that opens down, and then it'll be the point at the very top if that happens. Okay, but it's always on the axis of symmetry. It's always because it's in the very middle of the parabola, and so it's going to be either the highest point or the lowest point on the parabola depending on which way it opens. Okay, so next page, let's look at another equation. So this is y equals -x squared. So let's see what happens with this. So when I plug in these different x values, I'm going to put what I'm substituting in parentheses like that. Okay, so I'm taking 0 squared, which is 0, and then I'm taking the opposite of that. Well, the opposite of 0 is 0. So 0, 0 is on the graph again. Okay, then when I plug in 1, 1 squared is 1, so I got -1, -1. Okay, and when I plug in a 2, let's see, I've got -2 squared. So I got the opposite of 2 squared. Well, 2 squared is 4, so this is going to be -4. Okay? And maybe you can see the pattern, right? So I'm going to square it and then take the opposite. Square it and take the opposite. So squaring 3 is 9, and then take the opposite, -9. Okay? When I square -1, let's take a look at that. I'm doing the squaring first, right? You got to follow PEMDAS because I've got an exponent, and then this is like multiplying by -1. So I'm going to do the exponent before the multiplication. So I'm going to square first. -1 times itself is +1. Then I'll multiply by -1. Then I'll take the opposite, so -1. Okay? So again, I'm squaring and taking the opposite. Squaring gives me 4, but then the opposite of 4 is -4. Squaring this gives me +9, but I'm taking the opposite then. That gives me -9. Okay? So let's plot the rest of these. 1, -1, 2, -4, 3, -9, and then I've got the mirror image of those points on the other side. And you might have guessed just from the provided graph, this one is going to open downwards, right? So it looks just like the last graph, except it's opening down instead. And that is always going to happen when you've got a negative in front of the x squared. It could be -7x squared or -19x squared, but if there's a negative coefficient in front of the x squared, then the parabola opens down. So that's what I got right here. If the x squared term is negative, it's always going to open downwards. Okay? All right. So you could think of that as a reflection over the x-axis. Sometimes you'll see that because here's the x-axis. If you reflected your original parabola over that, then it would look like that. Okay? All right. Let's move on. So y equals x squared is graphed. Okay, here it is. We're going to graph y equals 2x squared and y equals 1/2 x squared on the same coordinate plane. Okay? So let's think about this. If I plug in a 0 into this, I'm just going to do this in my head so I don't have to write all of it down. But 0 squared is 0. Then multiply that by 2. It's still 0. Okay? If I plug in a 1, 1 squared is 1. And if I double that, I get 2. If I plug in a 2, I get 2 squared is 4. If I double that, I'll get 8. And if I plug in a -1, -1 squared is +1. Then multiply by 2. That would be +2. -2 squared is 4, then double, I get 8. Okay, so you're squaring first, then multiplying by 2 on each of those. So let's see what this one looks like. 0, 0, so same vertex. Then I have 1, 2, so 1 to the right, 2 up. 2 to the right, 8 up. It's right here. I got -1, 2, and -2, 8. Hey, look at this. So the parabola is going to be a little bit different shape. It's going to look narrower. Okay? So just to label this, this was y equals 2x squared, that one. Okay? All right, so let's look at y equals 1/2 x squared. So take the 0, square it, that's still 0, and then when you multiply 0 times 1/2, that's 0. Okay? If this was 1, I've got 1 squared is 1, multiply that by 1/2, it's going to be 1/2, so I'll just write that as 0.5. Okay? And then if I plug in a 2, 2 squared is 4, and then 4 times 1/2, that's like taking 1/2 of 4. Well, half of 4 is 2. Okay? When I plug in a -1, -1 squared is 1. Multiply that by 1/2, that's 1/2. And then when I plug in -2, that would be -2 squared is 4. Half of that is 2. Okay? All right, let's plot these. Let me use I'll use a different color here. Let me use a highlighter here. So 0, 0. And then I've got 1, 0.5. That's something like that. And 2, 2. And then it looks the same going to the left. So -1, up 1/2, and then -2, up 2. And I've got something that looks like so. Okay. So this parabola is going to look something like that. And you might notice this one looks wider than the original one. Okay. So that brings us to a vertical stretch or compression. So if you think about the points on the on y equals x squared. Sorry, let me label this one before I forget which one this was. This was y equals 1/2 x squared here. Okay, so if you think about the points that we plotted originally on the y equals x squared, we went up 1 to the right 1, up 1 to the left 1, and then we went up 4 to the right 2, up 4 to the left 2. Okay, I'm not going to plot the next points. But we've got here, when we're talking about the red parabola, if you take these points and stretch them up, so if these points would go up, these points would go up, that's called a vertical stretch, okay? And anytime that coefficient is more than 1, you're going to get a vertical stretch, okay? And actually, if it's less than -1, the same is true. So that's why I'm saying the absolute value of A is greater than 1. Because if you have a negative, it just makes it open down, but you could still get a vertical stretch, say, if you had y equals -2x squared. The negative would make it open down, the 2 would give it a vertical stretch. So when we have a number more than 1, or less than -1, it's going to give you a vertical stretch, and the parabola looks narrower. So I'm just going to say the parabola looks narrow compared to the parent graph, okay? You could also have what's called a vertical shrink in it. That means if you're taking these points, they're moving down, straight down towards the vertex. So here towards the x-axis. So that's a vertical shrink, and that's it's sometimes called a vertical compression. That means the same thing. That's going to happen when your A value is less than 1. So the parabola is going to look wide when that happens, okay? It's when it's between 1 and -1 on the number line. So it could be less than 1, or it could be also greater than -1, but in between 1 and -1, okay? Okay, so there's two types of transformations that we have looked at now. That we've looked at these vertical stretches and shrinks, which would make the parabola look wider or narrower. And then we've also looked at reflections, reflecting over the x-axis, which would make a parabola open downwards if you've got a negative coefficient. Okay, so let's try some on the next page here. So this says graph the function and compare it to y equals x squared. So y equals x squared is already graphed. And hey, I'm just going to put these are called critical points. I got the vertex, and I'm going to put that next set of points in so we can compare to those, okay? So now we're going to graph y equals 1/3 x squared, okay? So if you think about what we did on the previous page, that should give me a vertical compression. So what I'm going to do is just make an xy table. But what should happen, since this is a number less than 1, is my parabola is going to look wider. Okay, so let's test it out. Let's plug in 0 for x, and I'll plug in 1 and 2, and I'll plug in -1 and -2, because those are the x values that I have for these critical points. Okay. So let's think about that. When I plug in a 0, 0 squared is 0, multiplied by 1/3, still be 0. Okay, so the vertex is still 0, 0. And then when I plug in a 1, 1 squared is 1. 1 times 1/3 is 1/3. So I'll just leave that as 1/3 there. Okay, if I plug in a 2, here, let's try this out over here. So I've got 1/3 times 4. Well, that's going to be 4/3. Or you could think of that as 1 1/3 if you wanted to, okay? So maybe I'll 1 1/3 or 1.3 repeating. Maybe I'll put it in as 1.3 repeating like that, okay? So 1.3333, okay? When I plug in a -1, -1 squared is +1. Multiply that by 1/3, okay? And when I plug in a -2, I'm going to get +4 when I do the squaring, multiply by 1/3, that would be 4/3 again, which would be this number, okay? So let's go ahead and plot those. So I got 0, 0, that right vertex is in the same place, then I have 1, 1/3. So 1 to the right, 1/3 up. I'm just eyeballing this, that's like a third up there, okay? And then 2, 1.3 repeating, so 1 1/3, something like that, okay? And the same pattern is going to happen, mirror image of those is going to happen going to the left. Okay? And when we draw in the parabola, it will look wider because these points have been squished down. They've been vertically shrunk down towards the vertex. Okay? So when it says compare, I want to say, okay, well, this is a vertical shrink by a factor of 1/3. Okay, when I say by a factor of 1/3, that means my new parabola is 1/3 the height of the original parabola. So it's been shrunk down to 1/3 of its original height. Okay. Okay, let's try out another. So this one, I've got two things happening. So I'm going to do an XY table, but just looking at this, the negative, that means this is going to open down. Okay, so just from that, I know I'm going to get a parabola that looks something like that. Okay, and then the 3, I'm going to kind of look at that separately. The 3 that's a number more than 1, so that means this should be a vertical stretch. Okay, so that means my parabola should look narrower because the points are going to stretch away from down away from the vertex. Okay, but let's try putting some points in. So this is y equals x squared that I already had graphed here, right? Let's put in the critical points just for comparison purposes. Okay, so I know it's going to be opening down, so let's see if that works out algebraically. When I plug in, I'm going to plug in 0, 1, and 2 going to the right, and -1 and -2 going to the left. Okay, so when I plug in a 0 into this, let's see, -3 times 0 squared. 0 squared is 0. Multiply that by 3, it's going to be 0. Okay, when I plug in a 1, so I'm going to get -3 times 1, which is -3. When I plug in a 2, I'm going to do the squaring first. So I got -3 times 4. That's going to be -12. Okay. And then let's see, when I plug in a -1, so do the squaring first, then the multiplication, I get -3. And when I plug in -2 into the equation, almost off screen there, zoom out a little bit, then I've got -3 times 4, which is -12 again. Okay, so let's start plotting these. So I've got 0, 0, I've got 1, -3, and then I've got 2, -12, and I didn't leave myself quite enough room on this graph, so let's extend this a little bit. I'll fix that on the note-taking guide. So 10, 11, 12. Okay, so I do have enough room. Whoops, should have been right there. This is 2, -12, okay? And then -1, -3, and -2, -12. Okay, and then let's draw in this in. Something like that. Okay, and now making the comparison in words. Well, I kind of did it already, but yeah, we did. It opens down, so we can call that a reflection over the x-axis. This is flipped over the x-axis to make it open down. So reflection over x-axis. That's one way that it's different from the original. Okay, and then we had a vertical stretch by a factor of 3, which means this is I mean, it's not tall, but it's those points have moved 3 times as far vertically away from the vertex. So yeah, vertical stretch by a factor of 3. Okay, all right, that is the end of the section, and I'll see you next time.